to improve Oracle insert, update, delete queries. To improve Oracle insert, update, and delete queries, you can consider the following best practices and optimization techniques. Use appropriate indexing. Ensure that the tables involved in the update operation are properly indexed. Indexes can significantly speed up the update process by allowing efficient data retrieval and modification. Analyze the query execution plan to identify any missing or underutilized indexes and create or modify indexes accordingly. Use the where clause effectively. When updating or deleting records, use the where clause to specify the exact subset of data you want to modify or delete. Make sure your where clause is properly constructed to target the specific rows you want. Using appropriate conditions and operators can help Oracle narrow down the rows to be deleted, reducing the overall processing time. Batch processing. Instead of executing individual insert, update, or delete statements, consider using bulk operations or batch processing techniques. For example, you can use the insert all statement to insert multiple rows in a single statement or the merge statement to perform efficient updates or upserts. Use bind variables. Rather than hard-coding values directly into the insert statement, use bind variables. Bind variables allow the Oracle database to reuse the SQL statement with different parameter values, which improves performance by reducing parsing and optimizing time. Reduce unnecessary triggers and constraints. Evaluate the triggers and constraints on your tables to ensure they are necessary. Unnecessary triggers or constraints can slow down insert, update, and delete operations. Optimize rollback segments and undo table spaces. Properly size and configure the rollback segments and undo table spaces to avoid contention and optimize the performance of your modification queries. Direct path insert. If you're loading a large amount of data into an empty table or appending to an existing table, consider using Oracle's direct path insert option. Direct path insert bypasses the database buffer cache, writing data directly to the data files. This method can be faster for bulk inserts but may require some additional considerations, such as temporary space requirements and impact on concurrent transactions. Parallel insert. If you have a system with multiple CPUs and I/O resources, you can take advantage of Oracle's parallel insert feature. By specifying the appropriate degree of parallelism, Oracle can distribute the insert workload across multiple processes, leading to faster inserts. However, be cautious while using parallelism, as it can increase the resource consumption on the database server. Reducing logging. Oracle maintains a redo log to ensure data consistency and recoverability. However, excessive logging during insert operations can impact performance. If you can afford to sacrifice some degree of recoverability, you can switch to the no logging mode for the insert operation or consider using direct path insert, which reduces logging. Optimizing commit frequency. Committing a transaction frequently during the insert process can impact performance due to the overhead of disk I/O and log file synchronization. You can optimize the commit frequency by using a larger batch size or committing after a specific number of rows, depending on your application's requirements. Partitioning. If you're dealing with large tables, partitioning can provide significant performance benefits for insert operations. Partitioning allows you to break the table into smaller, more manageable pieces, enabling parallelism, faster data loading, and improved query performance. Regularly analyze and gather statistics. Keep the table and index statistics up to date using the Oracle Analyze or DBMS_stats package. Accurate statistics help the optimizer make better decisions and choose efficient execution plans. Regularly tune and monitor the database. Keep track of your database's performance metrics, identify bottlenecks, and take appropriate actions. Regular monitoring and tuning can help you identify and address performance issues in a timely manner. How to improve apply lag on an Oracle standby database. To improve apply lag on an Oracle standby database. Optimize network bandwidth. Ensure that the network bandwidth between the primary and standby databases is sufficient to handle the amount of data being transferred. You can also consider using compression and tuning TCP parameters to improve network performance. Optimize redo transport. Ensure that redo transport is configured properly. You can use the async mode for redo transport to reduce the time required to transfer redo data over the network. Optimize redo apply. Ensure that the standby database is configured for optimal redo apply performance. This includes setting appropriate parameters for the redo apply rate and tuning the size of the redo log files. Use fast start failover. Fast start failover can be used to reduce the downtime of the standby database in case of a failure. This can help reduce the apply lag as well. Optimize disk I/O. Ensure that the disk I/O subsystem on the standby database is configured properly. This includes using RAID or other disk striping technologies to improve disk performance. Use Oracle Active Data Guard. Oracle Active Data Guard can be used to improve the performance of the standby database. This technology enables real-time reporting and querying on the standby database without affecting redo apply performance. Monitor and troubleshoot. Monitor the standby database regularly for any issues or errors that might impact the apply lag. Use Oracle Enterprise Manager or other monitoring tools to track performance metrics and troubleshoot issues as they arise. How to improve transport lag between primary and standby database. To improve the transport lag between a primary and standby database in Oracle. Increase the network bandwidth. Ensure that the network bandwidth between the primary and standby databases is sufficient to handle the data replication traffic. If possible, upgrade the network connection to a faster one to reduce latency. Optimize the network configuration. Tune the network settings such as TCP window size, packet size, and socket buffer size to optimize the network performance. This can help to reduce the time required to transfer data between the primary and standby databases. Optimize the redo transport configuration. Tune the redo transport configuration parameters such as the maximum transmission unit, MTU size, network timeout, and acknowledgement frequency to optimize the redo transport performance. Use compression. You can enable compression for the redo transport traffic to reduce the amount of data that needs to be transmitted over the network. Use asynchronous redo transport. Asynchronous redo transport mode can improve the replication performance by allowing the primary database to continue processing transactions while the redo data is being transferred to the standby database. Monitor and tune the system. Continuously monitor the replication lag and tune the system parameters accordingly to ensure optimal performance. How to improve I/O utilization in an Oracle database. Improving I/O utilization in an Oracle database can have a significant impact on performance. Implement proper storage configuration. Use a storage system with high-performance disks, such as solid-state drives (SSDs), to reduce disk access latency. Configure appropriate RAID levels, example RAID 10, to balance performance and fault tolerance. Align the database files and file systems with the underlying storage to avoid misalignment overhead. Spread data files across multiple disks. Distribute your data files across multiple physical disks or disk groups to leverage parallel I/O capabilities. Create multiple Oracle tablespace data files on different physical disks to allow concurrent I/O operations. Optimize database layout. Separate the database files, data files, redo logs, control files, onto different disks or disk groups to reduce contention. Place frequently accessed tables and indexes on faster storage to improve I/O performance. Use the Oracle Automatic Storage Management (ASM) feature to optimize I/O distribution and striping. Implement appropriate database block size. Choose the appropriate block size, usually 8 kilobytes or 16 kilobytes, based on the workload and I/O characteristics. Larger block sizes can be more efficient for sequential I/O, while smaller block sizes can be beneficial for random I/O patterns. Optimize I/O operations. Enable asynchronous I/O, AIO, to allow overlapping of I/O operations with other processing. Use direct I/O rather than buffered I/O, which avoids double buffering and reduces CPU and memory overhead. Adjust Oracle I/O related parameters like db_file_multiblock_read_count and file systemio_ options to match your workload. Use Oracle Advanced Compression. Compressing database files can reduce the I/O required to retrieve and store data. Oracle provides various compression techniques, such as advanced row compression and advanced LOB compression, which can be applied to specific tables or partitions. Monitor and tune I/O performance. Regularly monitor I/O performance metrics using Oracle's performance monitoring tools, example Enterprise Manager, Automatic Workload Repository. Identify and analyze I/or related bottlenecks, such as high wait times or I/O contention. Consider implementing Oracle's Automatic Storage Management, ASM, or Oracle Exadata for optimized I/O management. How to improve CPU utilization in Oracle database. Improving CPU utilization in an Oracle database can be achieved through various methods. Optimize SQL queries. Poorly written or inefficient SQL queries can significantly impact CPU utilization. Analyze the execution plans of your queries using tools like the Oracle SQL Tuning Advisor or Explain Plan to identify bottlenecks and optimize them. Ensure you have appropriate indexes, use bind variables, and avoid unnecessary joins or full table scans. Tune memory parameters. Properly configuring memory parameters can help reduce CPU usage. Adjust the SGA, System Global Area, and PGA, Program Global Area, sizes based on the database workload. Oversized memory areas can cause excessive CPU usage due to increased cache activity, while undersized areas may lead to excessive disk I/O and CPU contention. Utilize Oracle Resource Manager. Oracle's Resource Manager allows you to allocate and manage system resources effectively. By allocating specific CPU shares to different users or applications, you can prioritize critical workloads and limit CPU utilization by lower priority processes. Use database performance diagnostics. Oracle provides various tools for performance diagnostics, such as Oracle Enterprise Manager, OEM, Automatic Workload Repository, AWR, and Automatic Database Diagnostic Monitor, ADDM. These tools can help identify performance issues, such as high CPU usage, and suggest recommendations for optimization. Consider parallel execution. Oracle supports parallel execution, allowing certain operations to be split across multiple CPUs. By leveraging parallelism for CPU-intensive operations, you can improve query performance and overall CPU utilization. However, keep in mind that excessive parallelism can lead to resource contention, so it's crucial to balance the degree of parallelism based on the hardware and workload. Update database statistics. Accurate database statistics enable the Oracle Optimizer to make better decisions when generating execution plans. Regularly gather and update statistics for tables, indexes, and system catalogs using the Oracle Gather Statistics feature or manually through the dbms_stats package. Upgrade hardware. If you consistently experience high CPU utilization and have exhausted software-based optimizations, upgrading your hardware can provide additional processing power to handle the workload more efficiently. Consider increasing the number of CPU cores, upgrading to faster processors, or utilizing specialized hardware options like Oracle Exadata. How to improve memory utilization in Oracle database. Improving memory utilization in an Oracle database involves optimizing the configuration and usage of various memory components. SGA, System Global Area, Configuration. Increase the size of the SGA to allocate more memory for Oracle's data buffers and caches. This can improve performance by reducing disk I/O. Adjust the sizes of individual SGA components like the buffer cache, shared pool, and large pool based on your workload and system requirements. PGA, Program Global Area, Configuration. Increase the size of the PGA to allow for more memory allocated to each session's private work area. Consider using the Automatic PGA feature, which allows Oracle to manage PGA memory allocation automatically. Shared pool. Monitor the usage of shared pool components such as shared SQL areas and PL/SQL procedures. Use tools like $SQL and $Sclaria to identify high resource consuming queries. Tune the shared pool by adjusting the shared_pool_size and shared_pool_reserved_size parameters. Memory management parameters. Set appropriate values for memory-related parameters like db_cache_size, shared_pool_size, java_pool_size, and large_pool_size. Consider using Automatic Memory Management, AMM, to let Oracle dynamically manage memory allocation. Automatic Memory Management, AMM. Enable Automatic Memory Management to allow Oracle to dynamically distribute and manage memory across SGA and PGA components based on the workload. Configure the memory underscore target and memory underscore max underscore target parameters to set the memory limit for Oracle's use. Buffer cache. Properly size the buffer cache, db underscore cache underscore size, to reduce disk I/O and improve performance.